Okay, guys, this is chapter 1, and chapter 1 is chapter is 11 in Timberlake, and in the book is chapter 11 as well, but that's the first chapter for us. We will introduce ourselves to organic chemistry. What is organic chemistry? Well, it turns out to be organic chemistry is called, has another name. Somebody will remind me what's the other name is? So, organic chemistry. Whoops, sorry. Let's see, allow me here a little bit to take it like this. Organic chemistry is called, equal to what? Somebody will tell me? If somebody will tell you what organic chemistry is carbon chemistry. So this is synonym of organic chemistry is the chemistry of carbon. So it's the whole organic chemistry is based on carbon. And then you will have other atoms will come in a question. But it's a must to have a carbon there, called carbon chemistry or organic chemistry. So, and as you can see, Johns Hopkins School of Medicine states, we cannot say we know the disease unless we have the chemistry and the organic chemistry principles and testing of that patient. So you cannot predict it. You have to have the testing and all this knowledge of the carbon chemistry. Okay, guys? So I'll take this one out. Second one. What's organic chemistry? Well, organic chemistry is about studying structural properties of organic compounds. That has, you can add to this here, that has, take the period out, that has carbon atom. Is a must. Beside carbon atom, you have hydrogen. Here, beside hydrogen. Now, sometimes you might not find hydrogen, but if you have you can have halogens, group number 7. We have the periodic table over there, group number 7. You can have nitrogen, but those it's not a must. But you have to have a carbon. That's a must. Hydrogen, well, you can have hydrogen most of the time, but not always. Some organic compounds, they don't have hydrogen. So, organic chemistry is the core of studies for those who seeks education in biochemistry, medicinal chemistry, pharmacy, pharmaceutical chemistry, primary health care, and medical profession. So if you want to specialize in one of those, you have to have organic chemistry. And organic chemistry, different from the general chemistry. General chemistry is this is just a pure organic chemistry, pure chemistry. No calculations, no math, no physics involved. So here we can see no physics concept involved, and no math. So in the past, people who had a little bit struggle with math, and they like chemistry, but they can't go for the other type of chemistry. They take organic chemistry because it has no math and no physics. So, but if you are interested in physics and math and chemistry, that's called general chemistry or principles chemistry. So the opposite of this is we call it principles or general chemistry. This is the opposite. This is the opposite of organic chemistry. Why? Because this principle or general chemistry is based mostly on physics. I mean, first is chemistry, of course. Physics and a lot of math. So whoever in love of math and physics and chemistry, there's three combination. This combination is called general chemistry or principles chemistry. Principles or general chemistry. And that's the difference between organic. Organic has nothing to do with math. You will not see me one time tell you a math. Correct? Maybe when we add some atoms, 2 plus 3, add just simple addition. That's not really math. But in chemistry, general chemistry and principles, there's a lot of physics concept and math concept beside chemistry. Okay, any questions so far, guys? Please raise your hand. Don't be shy. I'm here for you to help. Yes?
How do I join this meeting so I can see it from my eyes?
How you are?
How do I join this meeting on the board?
I can't hear you.
How do I join this meeting on the board?
On the board, you cannot. I have to record it first
Okay,
and then upload it to the announcement section.
gotcha.
Yeah, there is no live. I wish we had this opportunity, but I mean, we were given just a static software. Static means not dynamic, not live. It will be very nice if we have live, but I think the width band or the wavelength of the transmittance of the Wi-Fi might be blocked. I don't know, but you have concrete walls. It's not wood. If that's wood, it will be easy. But the concrete is always blocking part, absorbing part of the Wi-Fi transmittance. So I'm sorry, but I will. So if you are sick or something, you don't need to write me an email. I was sick or something, except for the 2 weeks here. Next week you have to sign. That's when we have to submit those grades to financial aid. But yeah, hold on. But what's happened is, if you are sick, you can come back and look at the announcement. You will see whatever we have covered there. You don't have to email me what we have covered, Dr. Atiyah. No, you have it there. You have everything there. But if you have a question after you have read and you have heard all the video there and you have questions, then we can meet one-on-one on WebEx. Yes?
For the quizzes and the exams,
Yes.
they don't have dates.
No, yeah, that's a good question. Why they don't have dates? As we finish the chapters, quiz number 1, chapter 10, 11, and what? What's it said there?
12.
And 12. So when we finish chapter 12, I will post for you for 1 week or 10 days the quiz. Are you following me here? So they are not dated yet. They will be dated as we go along. You see, in the past I was making some due dates, but it's very tough to adhere to those dates, to be really on time. Why? Because sometimes students are asking to go back and then explain the concept again. It's not understood very well. So it's very hard. It's very hard. So in English composition, I think history, philosophy, humanities, is very easy to have what they call it due dates on those quizzes. But science, physics, chemistry, biology is very tough because sometimes the concept or the what they call it, the content itself, it's difficult. I have to go back, and we have to go back together and revisit the whole thing and having some problems, some worksheets to see the whole thing. And it was a pain every time to change the due dates. So as soon as we finish the chapter, what it says, quiz number 1, exam number 1 is chapter 10, 11, 12. Finishing 12, I will tell you I'm posting quiz number 1, exam number 1 for 1 week or 10 days. So you have plenty of time to cover it. Everybody agrees on this? And that's very good. I mean, it's very, very difficult in science. I'm telling in chemistry. In physics, the same way. And biology, science and geology, all sciences is very difficult to be really restrictive with dates. But humanities, they read from a book. You understand my point? They read from a PowerPoint, just reading. And if you go for a history class or something, when you are in the back, you'll feel sleep because you can't read it yourself. That's nothing, But those sciences you have to be alert, you have to be vivid, you have to follow the PowerPoints, all details. It's not like humanities. Humanities is easy to grasp. That's my opinion. I took humanities classes. You are taking humanities, so that's easy. But chemistry is very tough too. I tried. This is I told you, my 27th years. I tried with this due date. It will never work. It will never work.
Well, doesn't the final have like a set?
Yeah, the final has set dates.
And which is that? Which days?
That's not set by the department yet.
Oh.
They will let us. It's not mine. See, that's the problem. See, we are working under the mercy of the department, and the department is working under the mercy of the administration. They need the data of the final exam for accreditation. They will let me know when is the final is. I'll let you know. Okay, so don't worry about the final. And it will be curved. And I'm telling you up front, don't be upset. The average on it is in the 40s to 50s. Most of our students are failing it, not because the concept is difficult, no. The time, they give you 70 questions in 55 or 60 questions in 55 minutes. And we'll have 2 finals, one for the organic part, one for the biochemistry part. We'll have how many finals? 2 finals. And will be taken on campus. So one is, I'll check with the department chair tonight and see what they decide, what they have decided. Okay, so organic part and the biochemistry part, so 2 parts. Okay, guys? So, any questions so far? So, organic compound, what's specific about organic compounds? Well, organic compounds, as I said, is a must. They have to have, this is a must, as I said. This is a must. M, capital U, capital S, capital T. If an organic compound does not have a carbon, it's not designated as organic compound. Are you following me here? Not an organic compound. Organic compound, they should have a carbon there. It's a must. And covalent bonds means they are not ionic. Not ionic means no metal involved. No metals. Okay? And low melting points, you know, they melt very low temperature, so 50, 60, 70 degrees Celsius. They low boiling points. The ionic compound, in the opposite, is just the opposite of the ionic compound. Ionic compound, they have higher boiling point, higher melting point, and they are combusted with oxygen. So they are combusted with the oxygen. A combustion reaction from 1151, if you recall, and I think everybody had taken 1151, and the type of reactions we said, you have taken this one in the lecture as well as in the lab. How many types we have covered in 1151? 5, single replacement, double displacement, combination, decomposition, and the 5th one is combustion. Combustion is reaction of any matter, reaction of the matter, like here we have methane plus oxygen. Anytime I have a reaction with the pure oxygen to give me CO2 plus H2O plus heat, this called here a combustion. This can be methane, can be any matter. Can be any matter. It has not to be organic. Sometimes if you have even inorganic, anytime I have used oxygen as a pure oxygen, let it react with any matter, a piece of paper, a piece of wood, a piece of metal. Anytime I use this one here, that will be called combustion reaction, and that's covered, I think, if you recall, back in 1151 in the lab and in the lecture. Combustion reaction is the reaction of any matter with pure oxygen. So that's a typical for organic chemistry. For organic chemistry, and as I said, combustion has two types, partial combustion and complete combustion. This is what I have here. That's a complete combustion. Called complete combustion. Complete combustion. But if I have a reaction here, it's matter, and then I reacted with oxygen, I get carbon plus CO2 plus H2O plus heat. That is incomplete combustion. This type of reaction is complete because I have a soot here. This is called here soot. And that's what you can observe in your chimney. When you burn wood, wood will not burn 100%. Part of the wood will give you what? Dark precipitate of carbon on your chimney. You have to clean after a while. After a couple of years, you have to clean the chimney. So it will become very, very dark because part of the incomplete combustion, part of the carbon called soot. And that's what makes the chimney very, very dark. Okay, guys, and that's called incomplete combustion. That's incomplete because you have carbon is not reacting all the way from the piece of wood there. Okay, guys, and the other one, and the organic compound in general, they are not polar. Meaning the good thing about them, they are not conducting any electricity. This is very important. Polarity here has to do with making ions and conducting electricity. So the organic compounds are non-polar, they are not conducting any electricity, and they are not producing any ions. Okay, guys? And they can form large molecules. And those large molecules they have specific name called polymers. Polymers. So polymer here. Polymers are organic compound that has a long number of carbon. They have long chain. They have huge number of carbon. 40 atoms of carbon, 50 atoms of carbon, 60 atoms of carbon. Those, they form large molecules called polymers. Correct? For example, a plastic. You know the plastic? You see the plastic bags? Those are called polymers. Those are organic compounds, but they have number of carbon inside very, very large. Any questions so far, guys, about this slide? Any question? Any question? Okay. Okay, so in order to understand the organic chemistry is always related to living creature, to living organism. And that's what's happened inside our body from the processes are always is come from the organic. The word organic is really means living. Organic means living. Okay, so and scientists concluded that it was only possible to make organic molecules at the laboratory if chemical process processed a special vital force said to be only found in living system. So we observe whatever is happening in the living body, in the living species, and then try to mimic these processes to manufacture those organic chemistry. Are you following me? That's what it says. A vital force theory here means organic chemistry, chemistry of carbon is based whatever is inside a living creature, a living body. So, and as you can see, there's a lot of metabolism inside our body is based on carbon. Of course, we have nitrogen and oxygen. We have some other elements, ions there, aluminum, zinc, magnesium, iron, all those there. But the most our body is really carbon. Carbon chemistry is there, and organic means living chemistry there inside. You will not see this inorganic chemistry plays a major role inside our body. Maybe in the stomach we have hydrochloric acid. It's only digesting some food there, or some bones, or some flesh, or some meat, whatever but that's very limited. But most of the processes inside the liver. So what do you think the liver is doing in our body? Can any creation, any creature live without a liver? Answer? Can? No. Why? You are almost there. Liver is a factory of 99, almost 90% or more of hormones. Hormones are controlling all the processes in our body, correct? Without those hormones manufactured by the liver, if the liver is dead, then we will not have any operation. We cannot even take our muscles up, take our muscles down, hands, I mean. So all those hormones are produced inside the liver. And small tiny ones inside the kidney, very tiny ones inside the kidney. But most of the hormones are produced in the liver. Whoever is alcoholic, he has to get rid of this because alcohols and all organic liquids are affecting the function of the liver, and that person mostly will destroy the liver. And if the liver is destroyed, no hormones will be produced, and most of the vital movement, vital thinking, vital motion of the body will be restricted, will be very highly restricted. So hormones are very, very important in our lives. Without hormones, we cannot live. And the same thing with the liver. It's very important. You can live with one kidney, but you cannot live without liver. You have to have it because it's called the manufacturing of hormones. It's a factory, called the factory. Another name of liver is called the factory of hormones. Okay, so next. So German scientist Friedrich Wöhler synthesized urine. By the way, it was not his intention to have urine, so that was just add those two chemicals, see what will happen. Urea is he produced urea. Urea is a very important compound inside urine. Urea is a very important compound in urine, and that's the fluid waste of the body of any animal creatures. So he mixed here the cyanate, took the cyanate, the sulfur cyanate here, took the sulfur cyanate, let it react with ammonium chloride, and with the reaction, this is sulfur cyanate, that's inorganic compound, this is ionic compound, that's ionic compound. Mix them together, he gets a precipitate, white precipitate of silver, that's a precipitate, and then another crystals of urea, and this is urea here, which is the vital compound found in urine. So urine is, I don't know, 80% of it urea compound. This is compound is coming out of the fluid waste of our bodies, of animal bodies. So that's for his surprise. He was thinking he will produce, something else, and he came up with a new compound. And this is organic compound, and not to his surprise, this is ionic, by the way. Silver is ionic, and this is covalent compound. So he has two compounds together. Urea is, if you have seen urea, is a white crystals, very nice white crystal, and sulfur chloride is a white crystals. So he can separate them by solvent. So sulfur chloride is not water soluble. The urea is water soluble, is fluid, correct? Is in our bodies. With tap or we drink, it goes out, cleans all the body itself. So this is water insoluble. So water insoluble, and this is water soluble. So you can separate those two by the solubility, by the polarity. So, so that's for his surprise. So that was the beginning of the organic chemistry. That's the beginning of organic chemistry. So he found the urea. I think the compound, it has a structure. If you look at the urea, it's like an amine group. It has, this is amine group, this is amine group, correct? And then you have like an amide here, I think. Here it is. Let's see. Ammonium thiocyanate, here it is. Let me see. Something looks like this here. It's you know, this is the urea itself. He was expecting this, but he got this, and this is just this is 2 here, H2. 2 amine groups with 1 carbonyl group. Looks like a ketone, but it's an amine. It's an amine because it has amino group, and 1 keto group. So that's a urea. So to his surprise, he was expecting to get this, but he did not get the ammonium cyanate. This compound called what? Ammonium cyanate. From silver cyanate, he would think it's ammonium cyanate, but to his surprise, he got the urea instead. It's a nice white crystals. So here is the conversion between organic versus inorganic. We said the organic chemistry, we can add to this. Organic chemistry, they have to have carbon. Carbon, here it is, we'll add this one. Carbon presence is a must. M-U-S-T, and then you just, correct? Here carbon presence, carbon presence is not a must. So we added to the table for our knowledge the difference between organic versus inorganic. The first one will come to attract your attention is that organic compounds or chemicals, they have to have carbon. That's a must. The inorganic, they might have, they might not have. So it depends on the compound itself, correct? So here it is. Well, that's, I rephrase this one here, which is really this one here. Okay? So, and the organic compounds are made with nonmetals, purely nonmetals, correct? So it's always nonmetals. Here we have metals and nonmetals, combination of both, correct? The attraction, small attraction of the molecules, so they are not polar. It means what? When you have a weak forces, dispersion forces between the atoms, that means you have non-polarity. So it means what? They are organic, not polar. And the opposite of this, because this one here, attraction will affect the polarity itself. Weak attraction means they are not attracted to each other, they are not polar. And here will come in this, they are mostly what? Polar. Okay? Example of this, you have some of them organic compounds are polar. Acetic acid polar, benzene is not polar, methane is not polar, correct? So, and here example of the sodium chloride, H2O, that's a covalent, correct? But it has what? It has ionic because it produces ions. Ionic means it has to produce ions. If this compound is not producing ions, called not polar, and it can be organic, but it has to have a carbon there. Without carbon, we cannot go nowhere without carbon. So it has to be made carbon and any other nonmetal. But carbon is a must. That has to be stated. That's the difference between them. So organic is a must to have carbon. The inorganic, they might have, they might not have. So, any question about this slide? Any question, guys? Raise your hand. So don't worry. I feel very happy if I'm challenged with questions. If I know the answer, I'll tell you. If not, I'll tell you. I'll check the answer if the question is difficult to answer. So, now back to 1151. Somebody remembers valence electrons? What's the definition of valence electrons? Somebody still remember? What's that? No. What we mean by valence electrons? Somebody remembers? Come on, guys. Yes. Correct. Electrons of a specific atom that are found in the last orbital or shell. Are you following me here? Not all the electrons. There are some electrons very close to the nucleus of an atom. They are not valence electrons. They are part of the core. So we have two types of electrons inside the atom. One of them, we call them core. Correct? So here it is. We call them core. And versus valence electrons. Correct? So the core they're very close attached to the nucleus. They cannot go nowhere. They are really like a magnet. They are really attracted too much to the nucleus. The nucleus will not let go. The valence electrons, they are in the last outer shell, the last orbital. So what's happened is the nucleus does not feel that it has control on them. So they can be easily given away, correct? Are you following me here? And you can add to them. You can give away, and you can add to those valence electrons. So, and that's the core is. Those are close to nucleus. And this is last orbital. Orbitals far away from the nucleus, far away from nucleus. So the nucleus has no control on them, although they are part of it, but the power of the attraction to the nucleus is very weak, and therefore they can go back and forth. You can kick them out, and then you can gain a couple of those inside. So when you lose one of those valence electrons here, when you lose one of those here, I don't know why let's see why. If we have one of those here lost, then you have a carbon that's missed one electron, correct? So therefore, when it's missed electron, it will appear like a cation, correct? So will be appearing like a cation. So when you lose one of those electrons, suppose you have, where is electron is? How many electrons? Carbon, correct? So if it's lose carbon, will be carbon plus one electron, because it's lost one. So this one has 3 electrons. This one has 4 electrons, valence electrons. That's what I'm saying. So 4 valence electrons, here is 3, and the number will appear plus, because in the neutral atom, number of electrons equal number of what? Protons, correct? But if you kick one of electrons out, you have what now? You have a positive carbon atom, because you have kicked out one of its electrons. And this one here, we will mention it in chapter 2, this is called carbocation, cation, carbocation. Remember in the 1151, we have anions, we have cations, correct? Because of the organic chemistry, now we say carbocations to designate this one here differently from the cations in the inorganic chemistry. So this is a cation, it's a positive, which is a carbon atom, neutral carbon atom that lasts what? 1 valence electrons. To designate it away from the inorganic cations, we say carbocations. Carbocations, which is carbon, we take the N out, just carbocations. And some books they said carbon cations. If you add the N, it will not harm, it's the same thing. But some textbook they said this carbocations. Anyway, so, and if you look at this, carbon has 4 valence electrons, nitrogen has 3, correct? Nitrogen will be appearing like this, 3 valence electrons. Oxygen has 2, 1 and 1, and chlorine has 1 only. Chlorine has 1 unshared electron, but chlorine has 7. So those are unshared, but oxygen has 6, by the way. So here 6, and nitrogen has 5, and carbon has 4. Okay, but the unshared ones is 1, 2, 3. Those are 4 unshared. Oxygen 1 and 2 unshared. Chlorine is 1 unshared. The other one is paired. Okay, bonding paired electrons. Those are the other ones. If I look here, those here paired. This is paired here. Those are paired. That's 3 sets of paired electron, and the blue ones are unshared. Those are by themselves, correct? So if I will ask you, what is a tumor? Now we are not. What is a tumor? If somebody has a cancer, what's the difference between tumor and cancer? Somebody has any knowledge, general knowledge? It's organic chemistry and inorganic chemistry. A tumor might be not dangerous if it's treated, okay, but what is a tumor? Well, it turns out the tumor is an atom with the free radical by itself. So it has 1 electron by itself, an odd number, correct? It has an odd number. So if I have an atom that has an odd number, an even number, single one is any atom, so X, and it has 1 odd single number, not paired, unpaired, correct? That's X, it can be any element, and it has an odd number of electron, single. This odd number is high energetic. That's a tumor. Will come and attack red cell, for example. This is a red cell here. That's a red cell. So this is a red cell here. So this odd number, like the ones we have in the blue here, those can be very, very, very dangerous if they have an atom as 1 free radical. It will come and attack healthy cells. It will chop it like you are with the scissor. This red cell will be chopped in thousands of small tiny cells, which then the brain cannot transmit any orders or signals to it to do any operation. Are you following me here? And that's, we call it tumor. Now, the small tiny ones, they have a free radical too. Each one has 1. They will attack any adjacent healthy red cells. And this stage, we say the tumors are spread out all over the bloodstream, and this stage is called cancer. So cancer is a spread out of tumors out of control through the blood stream. Are you following now? The tumor is a free radical atom within a cell that can attack healthy cells and break them in thousands of tiny cells, which the brain has no control on them and cannot transmit any signals or any orders to do any operation. Are you following me here? And if the brain fails to send any signals or any orders, then the person just, has to be put in the hospice. So you will see most of those people who are cancer related, they have cancer and the last stages of it, they have to be put in hospitals. Whatever medicine you give that person will not help, because it's just tumor is those free radicals come attack another red cell, that person may be within weeks will be dead, because the brain is malfunctioned. And if the brain malfunctioned, any operation will not work in the body. Everybody's following? It's the same idea here of this unshared electron. It's too dangerous to have an atom with the free radical. They call it this one here, an atom like this, called the free radical atom. Free radical because highly energetic. It's very radical. You have no control in it. It's just pumping and jumping all over the other healthy cell. Free radical atom with an odd number of electrons. Okay, guys? So that's an extra information, but it's very useful to determine what's the difference in tumor. Tumor, you have a free radical, odd valence electrons, one valence electron on this cell in any body, whether animal, by the way, even cells of, can trees have cancer? Yes or no? Yes. Cancer is nothing less than an atom that has a very odd. We don't know what's happened. Maybe it was from the lightning hit this tree and chopped some of the valence electrons of carbon there inside the wood. Tree can't have cancer. And that's what the source of cancer is not understood. Sometimes the brain is putting a lot of energy through the body, chopping those free radicals. And then the tumors is within. And that sometimes has to do with genetics. Some in the family has this disease. So the brain is pushing a lot of energy down to the cells, chopping it, and with the odd number of electrons, that one single tumor will affect the whole body itself. That's just for you, and I'm sure that a lot of you will go for nursing or dental hygienes. You should know when somebody will ask you about the source of tumor, free radical atom, and cancer, when you have those tumors are spreading all over the places, out of control. Now, somebody knows how to do the Lewis structure of those compounds? Somebody remembers? Let's do those together. Somebody remembers? No? 1151, guys? Lewis dot structure? No? Let's polish our memory here. Lewis dot structure. It's very important. This Lewis guy is very, very important, because he put the basis of the chemical compound structures. So, now, with looking at this, somebody will tell me what's the name of this? What's the name of this? We will cover this one later on, but that will be coming. This is called, if you cover this one here, and carbon has 4, correct? So it has 4 bonding, correct? 4 bonding, each one. So this carbon has 4. 1, 2, 3, 4. This one has 4. 1, 2, 3 here. This is single, not double. Don't come to the idea that's double. That's single here. and 4. So then you have H's all over. H, 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 and H. Those are 5. And the OH will come here. So that's alcohol found in wine, beer, all this type of alcohols. That's the major component on this in wine and beer and all type of alcohols. So that's ethanol. Why? Because this is 2 carbons, okay, will have eth. And then since it has OH, and then you add the OL, ethanol. So this is, OL is the OL here, those 2 here, for the alcohol. If I have 1, so that's carbon is 1, so that's meth. Those alkane, they have to end up with A-N-E. Methane. So this is meth. Carbon is meth. And this is alkane, will come in 2nd chapter, called methane. Methane. And if I have 2 carbons here, no OH, 2 carbons, and remember, this is the 2 carbons called eth, and since those are single bond, eth, and then that's alkane, A-N-E, eth. So you have 2 phrases. Eth because of 2, ethane, correct? And if I have 3, and all over H's, the 3 ones, carbon 3 will be prop. The 3 is prop. Then you will add single bonds here will add A-N-E. So 2 phrases, no spacing, but I don't know, there is no spacing, 1 word. But I want to just show you that's 2, this name and this name came from two things together, propane. And 4 called bute, and then ane. 5, pent, and then ane. 6, hex, ane, A-N-E, that's alkane. 7, hept, ane, 7 is hept. 8, oct, all those are Latin numbering. Oct, A. 9, no name. 10, deca. You heard the deca word? Deca means 10. Dec, ain. Are you following me here? So that's with the number of the carbons. It's very important to know how to deal with. And ane is because of the single bond. That's an alkane. We'll come back and cover this in chapter 2. But anyway, so any question about this? Any question so far? Any question, please? Any question? So we did this one, the first one. Let's do the second one. This one here called, that's a carbon, and it has, I'm doing this, carbon has hydrogen, 3 hydrogens, and 1 chlor. So this is called chlor. You start with the C, chloro, methane, 1 carbon, methane. This is called IUPAC naming, International Union for Pure and Applied Chemistry Society. They name the name. That's the actual real name, chemical name. International Union of Pure and Applied Chemistry Association. This is based, I think it started after World War II in France. Since that day, they are really spending their time on naming those compounds. So any compound name, you will see that they have a hand. However, sometimes we use what? We use common name. We use common name. Common name sometimes is nicer to use. What's the common name? Well, this is a myth, correct? So this is a myth. So whenever I want to relate it to something else, I add to it YL. So that's one word, but so methyl chloride. So the common name is called methyl chloride. Methyl chloride. But that's not the real IOBC name, the common name. Something like this here, guys, here. This is, common name is, the IOBC name is ethanoic because ethane, correct? And this functional group is carboxylic acid. So this one here, ethanoic OIC acid. So we'll come back to this, those are coming. Ethanoic OIC, we have to have ethanoic acid, correct? So, ethanoic acid. What's the common name of this? Acetic acid. Now we have a commercial name for this. So this one here as IUBAC name, which is this one here, IUBAC name, correct? And then we have a common name called acetic acid, correct? We have commercial name of it. What's the commercial name of it? Don't let me down. That's a commercial name. Vinegar. So we have, beside this, we have commercial names. So we have 3 types of naming. But what we are interested in, we are interested in this. We are not interested in common or commercial. I mean, it's good, it's a plus to know it, but we have to know how the IOBC name, the correct name, is there. So, any question about this? We have still 10 minutes. We can finish those here. So, this one here, you can tell that's always what? You have hydrogen here, the oxygen always likes to have always double bond. Nitrogen always triple bond. Carbon always single bond. So, carbon, single bond. But it can be double, it can be triple, but most of the time likes to be in a single bond, correct? And oxygen always in double bond, most of the time, double bond, but it can be single too. So, and nitrogen, those are the preference of those atoms. This is a triple bond. Those are preference, but it can be something else. That can be single bond too. Oxygen can be single bond as well, but that's most of the time the preference of those atoms. They like to be found in those status. So this is the Lewis structure of this. How about this one here? So what we call this one here? That's an aldehyde called what? Formaldehyde. Formaldehyde. It is what? Formaldehyde. Or formaldehyde, that's a common name. We call it, this is what? One carbon is meth, correct? And then because an aldehyde, add Al, methanol, methanol. That's IOBC name. That's what we are interested in, not the formaldehyde. Somebody will tell me what we use formaldehyde for? Somebody?
Preserving.
Correct. Did you Google it? No. So that's it. You'll see if you take biology classes, you'll see a lot of dead bodies there. A frog or a dead cat, whatever, they are preserved. They put formalin, combination of alcohol and formaldehyde together. So that's where methanol. That's a methanol. Now this one here, what we call this one here, this one will be looking like you have H, and H, and N, H, and H. That's an amine because the group, this one NH2, that's an amine. So that's what will be. Somebody will tell me. Methylamine. Methyl. This is a methyl group, and that's amine. Methylamine. Methylamine. That's a methylamine. Okay. The last one here, H, C, and the triple bond. The nitrogen likes to be in the triple bond. That's what. That's what. Cyanic acid, like hydrochloric acid, bromic acid, fluoric acid. That's hydrocyanic acid, hydrochloric acid. If you start H by itself, that's always the time will be an acid. Hydrocyanic, hydrochloric, hydrofluoric, hydrobromic. Okay, guys. So that's the structure of Lewis structure. Just to review, those are tough a little bit. So, question is, why CH5 and C2 are impossible to form? Somebody will tell me, looking at this, why? Can carbon has 5 hydrogens? Yes or no? Come on, guys, don't let me down. How many carbon does it have? 4 valence electron. When you add 5, where is the 5th hydrogen will go? So that can't be. It has only 4. So there is no space for the 5th one. 5? No, there is nowhere to 5th one. How about this one here? 2 carbons and 7 hydrogens. So we have 2, 3, 4, 5, 6. Where the 7 will go? No, that's violate what? The valence electrons rule. Carbon, the rule of valence electrons, you have carbon, nitrogen, oxygen, and fluorine. Those called CNF atoms, they have to have 8 octet, 8 valence electrons surrounding them. Look at this. This is 1, 2, 3, 4, 5, 6, 7, 8 for this carbon. This is octet. For this carbon, 1, 2, 3, 4, 5, 6, 7, 8. Octet rule. You cannot violate the octet rule of those 4 elements, CNOF. And that's a repeat of the survey of chemistry 1. Okay? Any question about this, guys? Any question? We are repeating survey of chemistry 1 a little bit so to help us to understand. So, methane, that's the first one. We said the methane, and we'll talk about the hybridization later on. This is just the hybridization is called sp3 hybrid. The carbon is hybridized by sp3 hybrid. The bond angle here between carbon and this is 109 degrees, 109.5 degrees. Correct? This one here, when I say like this, dark, that's sticking out. The atom sticking out. When I say like this, that's in the back. So when I have those here, look at this again. Look at this. So this atom here, this one here in the back, this one here up front. So the darker arrow here sticking towards you, and the dots ones in the back. Everybody agrees? We'll see a lot of structure like this, so you will know from now on. If I have a dot as a single bond, means this atom in the back of the molecule. When I have it up front, I put the solid one towards me. Correct? So that's methane, and it has the geometry here. The molecular geometry is tetrahedral. So the geometry is tetrahedral. And the bond angle is 105. Somebody has taken 1151? Visper? Remember Visper, guys? That's Visper. So that's Visper. So you should review the Visper stuff here. So that's the hybrid is sp3. The hybrid is sp3. So, and structure for organic compound. We talked about whisper, tetrahedral, and if I have, depending on the whisper rule, tetrahedral is the hybridization sp3. This one here sp2, and linear is tetrahedral is sp3, and this is linear is sp. Okay, guys, that's the hybrids when those atoms come together, the carbon atoms. That's what I'm speaking about. The carbon, they come back. So linear is for triple bond, sp2 for double bond, and sp3 for single bond. I'll stop here, guys, stop recording, and I'll give you 1 minute so you can. So, okay, guys, so any question you have, I'm open for any question. Yes?
I'm kind of just confused because a lot of the stuff that you was going over is like out of order. So like, I know, because I'm taking Chem 2 again, but I know when we started, we was learning about the alkenes, alkynes.
That will come.
Okay.
Introduction. The first chapter is the introduction.
Because I'm like, why are we talking about ethers and amides and amides? And like,
Those
that's
are
so
chapters
far.
coming.
That's
Those
so
are coming
far.
on. That's introduction.
Okay.
If you look at Timberlake, the first chapter 10 is introduction.
So basically,
You have to be introduced to all the function groups and to all type of bonding and a little bit of hybridization. Yes, that's all introduction.
I'm so confused. It's so out of order.
No,
but basically, you're
no.
just giving us like
Introduction.
a run. Okay.
Yes, that's combining Survey of Chemistry 1 and Survey of Chemistry 2. Now, if you go now chapter 2, now we talk about alkanes, alkenes, and alkynes. That's it. Are you following me? Then we'll talk about the ketones. Then we'll talk about aldehydes. Yeah, but the first introduction has to give you an overview of all will be covered. Are you following me here? So now if you go to Timberlake or you go to our ebook, that's the whole thing is. Maybe the instructor of yours last time did not cover the first thing. But I like to cover the first thing to give the students the feeling how those chapters will be. So the first chapter is introduction to whole 10 chapters or 11 chapters. That's about it. Any other question? Any other question? So that's it. Thank you very much. I'll stop recording here.